10 billion square meters represents the total area of drywall produced annually across the globe. This volume is sufficient to cover millions of homes from the United States to Europe. One can notice how the material acts as the rigid backbone of modern construction projects. But this is just the beginning. Why has this product become the #1 choice for builders? It supports structures on every continent without fail. The answer lies in the transformation of raw minerals into flat walls through a precise sequence. At first glance, the sheet seems simple, but in reality, it hides an incredibly complex industrial process. Massive factories operate non-stop to create these millions of units for distribution. It gets more complex further on. The manufacturing line starts its motion, leading the material toward its final form. 95% of United States homes use drywall for ceilings and walls, making it the most common material in residential construction. A core of ground gypsum powder is pressed tightly between 2 layers of tough industrial paper. One can notice how this compression creates a solid, lightweight panel. But this is just the beginning. The material offers more than just structure. Why is the gypsum core so essential? It seems like a simple filler. In reality, it provides fire resistance and sound insulation better than many traditional materials. A standard 4 by 8 foot sheet costs $10 to $20. At first glance, it costs more upfront than wood or plastic, but quick installation makes it worth the investment. Low maintenance ensures value in the long run. The surface is ready for finishing. Dozens of meters of solid rock conceal the mineral deep within massive mountain ranges. The first step in making a gypsum board begins here, where the material lies deep underground and is accessed through large open pit mines. Powerful drills bore holes dozens of meters deep, creating shafts strong enough to hold explosives. Specially designed charges are packed deep into the rock to ensure a clean break. Why is the precise calibration of these explosive charges so critical? The rock face stands imposing and unyielding against simple tools, because uncontrolled force would destroy the resource. The blasts are carefully calculated so that when detonated, entire layers of gypsum break free from the mountain. The chief supervisor gives the command, and the blast is triggered, sending thousands of tons of gypsum crashing free from the mountainside. Dust slowly settles, revealing the fractured layers of ore. The mineral is released and made ready for the next stage of its journey. But this is just the beginning of the logistical operation. At first glance, the site looks like chaotic destruction, but massive excavators move in on the piles of freshly blasted gypsum with organized precision. It is visible how the buckets scoop up chunks that weigh several tons at a time. Each machine works in rhythm, loading the mineral into the beds of smaller, specialized trucks. These trucks rumble down dusty paths, carrying the gypsum to a temporary staging area. Transition to the next level involves a change in scale. Therefore, the loads are transferred once again, this time into giant heavy-duty haulers built to handle massive volumes. One can observe the massive tires compressing the earth as the gypsum begins its journey to the processing plant. The raw stone is now fully committed to the transformation into essential construction material. Several dozen tons of gypsum rocks roll steadily into the plant's receiving area inside the bed of every single heavy-duty truck. These vehicles arrive in a continuous stream, dumping their payloads straight into a massive storage yard, positioned immediately adjacent to the primary processing line. Engineers on site meticulously record the numbers and manage how the raw material is distributed, preparing it for the initial stage of mechanical crushing. On average, this facility takes in and processes more than 100 trucks a day, adding up to thousands of tons of raw gypsum entering the production flow every 24 hours. Why is such a massive and uninterrupted flow of raw material necessary for the plant? It would seem that the stockpile is already sufficient for days of work, but without a constant replenishment of the yard, The high-capacity kilns and conveyors would run dry within hours, halting the entire manufacturing chain. Excavators move into the storage yard, scooping up massive loads of gypsum rocks piled high in front of them with hydraulic buckets. They work in a steady rhythm, dumping the mineral straight into the feed hopper of the production line with a heavy thud. From there, the large chunks are carried into giant crushers that await the raw stone. One can notice how the steel jaws of the machinery accept the rock, preparing to reduce the geological formations into workable material. The crushing step breaks the rocks down to smaller pieces, making it easier for the drying process that follows immediately after. The gypsum crusher works with two massive rollers that keep turning, applying heavy pressure on the rocks fed inside the mechanism. Large chunks get gripped tightly between the steel cylinders and break apart into smaller pieces under the even force spread across the roller surface. Thanks to its steady motion, the crushing energy is used efficiently, making the size reduction more effective. The result is a continuous flow of crushed gypsum pouring out from below like a gray landslide. These gypsum rocks contain as much as 70 to 80% pure gypsum, and they are crushed down into particles only a few millimeters across. However, this process generates a huge amount of dust, and if workers breathe it in over long periods, it can lead to serious illnesses like lung cancer. But this is just the beginning of the transformation. Conveyor belts, massive in scale, carry the ground material deep into the heart of the plant. These belts stretch hundreds of meters long, running non-stop at a steady pace to keep the flow of material completely uninterrupted. Thanks to the automated transport system, every particle of gypsum is delivered straight to the drying and processing area for the next stage of production. After grinding, the fine gypsum powder is fed into a giant rotary kiln for the critical heating process. During this stage, calcium sulfate dihydrate slowly loses water and transforms into calcium sulfate hemihydrate, commonly known as calcined gypsum. Flames from the burner shoot directly into the kiln, creating temperatures that range from about 300 degrees up to over 660 degrees, with some hot spots reaching close to 600 degrees. The heating usually lasts for hours, allowing the water to be released gradually so the crystal structure does not break down too quickly. Engineers carefully monitor and adjust the controls, keeping temperatures steady in different zones of the kiln. This strict level of control produces high-quality gypsum powder, ready to move on to the next mixing stage. Once the heating process is finished, the gypsum powder is sent to the mixing area to be prepared into slurry. At first glance, mixing powder with water seems like a simple routine operation, but in reality, it is a chemically complex stage where the stability of the final product is determined. Before blending the entire batch, technicians take a small sample to the lab for rigorous testing. There, the powder is mixed with water in a set ratio and combined with specialized additives like starch or setting time modifiers. The mixture is stirred thoroughly, then monitored for expansion, strength, and setting time. Results are compared against the required quality standards, helping engineers confirm the stability of each production lot. Thanks to this testing step, the plant makes sure the gypsum going into mass production always meets the highest level of reliability. Once the formula is finalized, the automated system starts blending the gypsum powder with water and additives in the exact ratio. Each batch of raw material quickly turns into a thick slurry ready for the next step, molding. Drywall is not made of just gypsum powder inside. It is tightly sandwiched between two layers of paperboard, which adds strength and prevents warping. That is why massive rolls of paper, stretching hundreds of meters long, are fed into the production line as an essential component. Specialized machines carefully unroll and flatten the paper, keeping the surface smooth and free of creases. Operators stay alert, adjusting speed and tension so the paper aligns perfectly with the line. This layer acts as the crucial framework, giving the gypsum a solid base to bond with and forming a complete drywall panel. Right after that, the gypsum slurry is powerfully sprayed onto the flattened paper surface. High-speed nozzles spread the slurry evenly, forming a continuous and uniform layer across the moving sheet. This allows the gypsum core to bond tightly with the paper, laying the foundation for a complete drywall panel. It gets more complex further on. The layer of gypsum slurry spread over the paper passes through a massive roller system to set its precise thickness. These rollers are designed to turn continuously at a steady speed, pressing lightly on the surface of the mixture. With controlled pressure and accuracy, the entire gypsum layer is leveled evenly from edge to edge. The thickness of a drywall sheet usually ranges from 9 to 15 millimeters, depending on the type of product the plan is making. This step ensures that every drywall panel coming off the line has consistent dimensions, ready to meet the demands of modern construction. Right after the gypsum layer is flattened, an automated spray system mists a thin solution over the surface. This coating works to eliminate tiny air bubbles that form during mixing and spreading. If left untreated, those microbubbles could create voids and weaken the drywall panel significantly. The solution is usually clean, filtered water, sometimes mixed with additives to improve adhesion. The droplets are ultra-fine and evenly distributed, so they do not deform or disrupt the panel as it is taking shape. It is visible how the mist coats the surface without disturbing the underlying structure. Thanks to this controlled spraying step, the product keeps a uniform structure and a smoother surface finish. After that, the edges of the drywall panel are precisely shaped by specialized machines, creating clean and even outlines. This step gives the product neat edges, making it easier to join and install at construction sites. Once the drywall panel is fully formed on the conveyor, it moves into the automatic cutting area. Sensors precisely measure the length of each panel and send signals for the industrial blades to drop in perfect sync. The sharp blades run continuously, cutting the sheets into standard sizes like 2.4 meters or 3 meters, depending on production needs. The cutting speed is carefully calibrated to prevent cracks or surface shifts. Afterward, each drywall panel is separated and neatly arranged on the conveyor to move on to the next stage. Thanks to this advanced cutting system, the final product always meets consistent quality standards. And this is not the limit of the processing. The next step is crucial for the structural integrity of the sheet. Each drywall panel is folded so the paper wrapping tightly hugs the gypsum core inside. The mechanical system uses lifting arms and automatic guides to bend the moving sheet with high precision. As the paper folds over, it forms a sturdy cover, holding the gypsum in place and protecting the surface from cracks. Without this paper layer, the gypsum would crumble easily, making transport and installation difficult. At the same time, the paper creates a smooth finish that makes painting or tiling much easier later on. Thanks to this folding process, drywall panels gain the strength and clean appearance they need before reaching the market. After that, the drywall panels are moved into a massive drying chamber to remove any excess moisture left in the core. Inside, the temperature is maintained between about 300 degrees Celsius and over 660 degrees Celsius depending on the stage, and each drying cycle lasts around 30 minutes. Hot air is evenly distributed across all levels, making sure every panel dries consistently from the inside out. This step gives the drywall the hardness and strength it needs before moving on to the final finishing stage. Once the drywall panels are dry and stable, they move on to the edge sealing line. Machines apply special paper strips along the sides of each panel, both protecting and reinforcing their strength. The paper rolls come pre-printed with logos, product details, and technical standards, running continuously to keep the entire batch consistent. This process not only prevents edge chipping during transport, but also gives the manufacturer clear brand recognition. Forklifts carry stacks of finished drywall into the storage area, where they are neatly arranged into tall blocks reaching toward the warehouse ceiling. Thanks to this system, thousands of drywall panels can be stored efficiently, ready to fill large orders. Organized storage also makes loading faster and safer. When an order comes in, forklifts load each batch of drywall onto specialized trucks. From there, the fleet heads out of the plant, delivering the panels to construction sites and distributors across the market. Once drywall panels leave the factory, they are easy to install thanks to being lightweight, durable, and quick to work with. In the United States, more than 90% of homes today use drywall for interior walls and ceilings. The cost is also affordable, just a few dollars for a standard sheet, making it a popular choice. Its convenience and economy have made drywall an almost indispensable material in modern construction. "30 to 50 years is the average lifespan of a single drywall sheet within a European building structure. When a structure undergoes demolition, these panels are not simply discarded as regular waste to accumulate in landfills. Instead, specialized teams collect the material for immediate recycling, allowing workers to dismantle and sort the debris. This gives the gypsum a new life as part of sustainable construction. Why are these materials transported back to recycling plants in volumes reaching tens of thousands of tons each month? It would seem easier to simply mine fresh, raw material from the earth. However, recycled drywall costs 2 to 3 times less than gypsum extracted from quarries. Furthermore, this material can be recycled up to 10 times while maintaining nearly the same quality as the original product. Recycled drywall is lifted and loaded into industrial crushers. One can notice how the panels are ground down into a fine powder inside the mills. From there, the material moves to additional processing to become the raw ingredient for new panels. But this is just the beginning. Unlike in the United States, Europe has developed advanced recycling technology that specifically allows recycled paper to be added into the mixture. This paper comes mostly from sorted industrial and household waste, carefully cleared of impurities. At first glance, paper seems like a simple filler, but in reality, it significantly strengthens the internal bond of the product. This method also reduces the amount of raw material that needs to be mined. When combined with gypsum, it creates a building material that is both durable and environmentally friendly. The recycled gypsum and processed paper are fed into a modern mixing system. Here, the components meet water and additives designed to improve bonding strength. The equipment gradually blends the ingredients into a uniform slurry ready for pressing. The mixture is spread out into a wide layer, which initially appears soft and loosely formed. The process is only gaining momentum. Rollers and flattening systems press down on the mass, removing excess air and smoothing the surface texture. Automatic blades adjust the thickness, ensuring the entire sheet stays uniform from end to end. As the material moves along the conveyors, the layer is pressed and leveled several more times, turning into a continuous sheet. It is visible how the long strips approach the automatic cutting machine, where blades drop with precise timing to divide them into panels of standard size. And this is not the limit. This process runs continuously, ensuring every sheet matches the length requirements. After finishing, the drywall panels are neatly stacked into large bundles. Automatic packing machines wrap the edges to protect the surfaces and keep everything secured during transport. Thus, the product reaches customers flat, intact, and free from damage. 2 continents, from the Americas to Europe, encompass the full manufacturing path of drywall. It is present in the walls of most modern homes. But this is just the beginning of its utility. Why is the ability to be recycled many times crucial? It seems like a final state. This feature significantly eases the burden on the environment. At first glance, the product seems simple, but in reality, it carries a long story of technology. One can notice how the material returns to the mix without waste. The engineering ensures consistent quality. Thus, the production cycle remains continuous,